All right, folks, bienvenidos, welcome. Good to see you all, your bright, shining faces. I just have a few words before we get rolling. Also recognizing that some people are brand new here on day 2. First of all, as I was talking to Dr. M, it is really commendable that you folks are in this professional development situation right before the start of the semester when you've got a lot of other things that you're thinking about right now. So I just want to commend you for embarking on this journey. And I don't mean the 80s band journey, I mean your geospatial technology journey, that journey. Because truly, folks, what this is, and I'm going to stop the video to save the bandwidth right now, but what this is you're not going to learn all of geotechnologies in one day, right? Or 2 days. It's sort of like chemistry or physics or AP human geography or technology or anything else that you folks mentioned that you're teaching. It's a pathway. It's truly a lifelong endeavor. So that said, how can I, teacher that I am, and knowing what I have to do this semester, what pieces should I take from this workshop and incorporate in the classroom? That's, I know, a big charge, but that's where we want you to think about. We're going to give you, as you're encountering, a whole lot of different tools, lessons, data sets, and methods, field methods, classroom methods. And so we just encourage you to take 1 or 2 of those pieces and incorporate them this semester, right? Because we've all been in these situations, in these workshops in the past, right? It's, if you don't do it fairly soon, if you don't take 1 of those pieces, then you're stuck with, now it's November. And what did we do back in August again? What were Diana and Stanley and Joseph talking about way back in August? So that's why we encourage you to, start somewhere, but definitely start with something. And one of the first things we'll do today is build on those geo inquiries, those short lessons that we feel are one of the best ways to get started, okay? So, once again, bienvenidos, welcome, good to see you all. And I've got just a couple of words before we get rolling with our hands-on activity, okay, if you don't mind. How's everybody doing? Cool. There's a diversity of people there, and that's one of the things that I love about geotechnologies, is that you've got different levels, different backgrounds, right? Different subjects that you're teaching, but you're all focused on meaningful integration of technology, right? We're not doing geotechnologies just because it's there and it's kind of cool and so on. We're doing it because it's going to enhance what we're teaching and how we're teaching it. And so that's what I love about this. It's meaningful technology integration, not just because it exists and not just even because students can get jobs in this, which they can, as we talked about yesterday, in health, business, engineering, natural resources management, city planning, etc. There's lots of different fields that use geotechnologies. In my way of thinking, folks, it's kind of like an elevator. You get on it, you don't really think about the technology that makes it work. It just works. And when it doesn't work, then it's a problem, right? Same thing with geotechnologies. Those lights in your classroom right there at the middle school, the electric company, right, the power company is using geotechnology to manage all of the power lines and all the gas lines, so all the electric lines and the gas lines. Whatever you're having to eat there in the classroom today, right, that food service, that delivery was made possible through GIS. If you've got some like orange juice there, the orange growers, right, are using geotechnologies to manage their harvests. They're looking at weather, they're looking at soil type, amount of irrigation, etc., right? So power in the room, the food that you're eating, also the phone, right, that you've got with you, that smartphone, right, think of supply chain management, all the pieces that went into mining the minerals that make up that phone, manufacturing all those pieces, getting it to the market, advertising to consumers, all of those things that enabled you to get that phone in your hand or close by your side right now, that was all made possible with geotechnologies. The streets that you went through, this is the last example and I'll be quiet here. The streets that you went through to get to the middle school, right? The city has got the lights timed, not always how we would like them to be timed, but but according to their GIS, to their geographic information system that the city runs, to figure out, if they just make a little improvement in traffic lights, there's a lot of time saved, there's a lot of fuel saved, etc. So there's lots of things behind the scenes. And now with your teacher hat on, think about maybe using some of those phrases I just mentioned to introduce students to all of this. Why does this all matter? Well, because a lot of things actually that you've encountered today, you might not have thought about it, but everything from school bus routing to the electric lights in the room are based on and enabled by geotechnologies. Awesome. What's not to love, right, folks? So that might be one of the ways that you can introduce this with your students. Now, another thing I'd like to mention is that, let me share my screen here, because I want to show you something that I've done frequently in workshops and courses. So that, that activity that you just went around the room introducing yourself and so on and so forth, you can map enable that. So let's say you've got a classroom of students and you want to introduce them to a little piece of this geotechnology world, and you want to practice your own skills on creating a survey 1, 2, 3, which you talked about yesterday, and a story map that we'll talk about today. Well, one of the ways to do that is, for example, I've got this map, and I use this in several online courses, in my case, for teachers, for educators. And what they do is since it's online, they introduce themselves through a story map, okay? And so I ask them a few basic things like Dr. M asked you about, what's your background? How many years have you been teaching? And in my case, I asked them to submit a photograph, since they're from all over the world, of the landscape in their what it looks like at their school, at their place of work, okay? So let me just show you this ever so briefly, if you can see the screen here. But this is a crowdsourced story map. Now that's one way to do it. We'll build a story map today. The second way to do it, it would be with a survey 1, 2, 3. Set up a survey of, hey students, where have you been that's really cool that you want to share? Or where would you like to go in your lifetime? What would be the top maybe 2 places you'd like to visit, and why? So here's you guys seeing this okay? All right, so here's my course and workshop participants crowdsourced story map. And it's a simple, what does the landscape look like where you work? And so again, it took me literally, folks, about 10 minutes to set up. I had to decide what the questions would be. I had to decide what the content would be of the map. But once it's set up, then people can just click on this Explore Map. And as you can see here, I've got what's called a cluster map. So it basically aggregates, if you've got, let's say, look at that cluster of 30 points right around me in Denver. So a lot of the teachers in this course happen to be from the Colorado area. So this was, what does the landscape look like where you work? And so it's a cluster map, and as I zoom in, I can see that the numbers actually correspond to the number of points at that location. That's why we cluster it, so we're not seeing so many points in our face. That's one of the techniques we can use in ArcGIS Online. So if I click on, for example, some point on here, you can see that I'm getting the landscape that teacher, in this case, it's teachers that participated in the course, the teachers submitted to the story map. Does that make sense? So it's basically an online way of going around the room as you did, but it uses some of the tools that we've been using. In this case, like I say, it's a crowdsourced story map. So it's a kind of a story map that we're going to make today, but you just open it up to whoever you want to participate in it, okay? And another way to do that is with survey 1, 2, 3. So you set up a brief survey with the questions that you want, and all those results get mapped. Okay, so this particular person was from Durango, Colorado, along the Animas River, and it's the Purple Cliffs. Okay, so I just wanted to show that. Easy to set up. Like I said, 10 minutes to set up. And now I actually keep this live. So if you went to this, you can actually add. See, it says add your landscape up in the upper right. It's still live until the author of the map shuts it down. Let's say this was your map. You could have people participate until you decide to close it. Okay, so I just wanted to plant that seed. Another thing that I wanted to briefly mention is that this stool of geoliteracy, I call it, is really fundamental to what we're doing in these 2 days and beyond. So as you saw when we were working through your vegetation collection with Survey 123, did you folks enjoy that? I wish I could have been with you. All good? You enjoyed the field experience? Good answer. Okay, great. Super. Anyway, so that,
Okay.
looking at, yes?
Okay, I just wanted to chip in on that one. What they did yesterday was field data collection with portable GPS units. But
Right.
say they want to pray, they're going to do that this afternoon.
Wonderful. Okay, super. Thanks for clarifying. So you see that there's a variety of ways to get your data into a mapping program. None of them are very difficult, but there's a variety of pathways, and I think each of them have value in education. I think it's valuable to do what you did yesterday with the GPS units, because building a spreadsheet is really fundamental to GIS, right? It's the geographic part is the map. The I part is the information, the table that you build behind the map. That's what you were building yesterday, and then mapping it. And then the S part brings them together, the G and the I. We'll have more integration of those today. But this little diagram here, I just wanted to show that because in my way of thinking, and I think Diana and Stanley and others are sharing this, and that is you're not just teaching geotech. You're not just teaching geotechnologies, remote sensing, geographic information systems, web mapping, GPS. You're not just teaching those techie tools. So there are some skills there involved, but those skills are also presenting, researching, right? Communicating, working together. Those are skills too that you're fostering as you're working through geotechnologies. So there's the skills leg of the stool. And there's also, as you saw, hopefully yesterday, we're also teaching content knowledge, whether it's language arts or natural hazards, geography, geology, humanities, etc. Right? You're teaching some content knowledge as well, history, etc. Right? So, for example, when we went through that little watershed activity where we're looking at hydro with me briefly, we were looking at rivers and watersheds. What is a river? What is a river system? What is a watershed? How do they nest within each other? And then how does scale matter? So you're teaching some content knowledge as well. And then finally, you're also teaching the geographic perspective. Now, I know just a minority of you are actually geography teachers, and that's okay. The geographic perspective actually runs through other disciplines, in my view. It runs through history. It runs through language arts, PE, physical education, right? The geographic, spatial perspective. So thinking about the world, how it's changing over space and time. So the geographic perspective there. And also thinking about the world as a system of systems. The hydrologic system, right? The lithosphere, the atmosphere, the anthrosphere, the human component, and humans as change agents. So you're teaching all three of these things when you're teaching with geotechnology. That's one of the reasons why I love it. By the way, this slide is part of a presentation that is part of a story map, by the way. So oftentimes I present with story maps instead of PowerPoint or Prezi, or Sway. There's other good presentation tools, but I oftentimes teach with story maps as my means of presenting. So it's something to think about. As we mentioned yesterday, your students could actually present history of Texas as a story map. And maybe you give them an assignment, it's 3 frames in the story map, and then you will assess that, and they will present with that story map. Okay? So this is a story map that I'm presenting with right here. Okay, so and as you can see with a story map, you can have all kinds of multimedia in it. You can have graphs like I've got here, images, videos, maps, etc. Okay, a couple more things, and then we'll get started with our hands-on activity. One of the themes that's run through this workshop is being critical of data, right? Don't just accept it because it's online. Don't just accept it because it's a map. And inside this thing called spatial reserves, this is something that I update weekly, all about data. It's all about data and then crowdsourcing or citizen science. How do you know if data is any good? how to get students to really start asking those deep kind of questions with data. So spatial reserves might be something that would spark some conversations in class. For example, how many of you have a fitness app on your phone? Okay, so one of the things I wrote about not too long ago was the Strava fitness results map. And in there, in that particular post, I wrote about, hey, you know, Strava collects data from millions and millions and millions of people's fitness walks. So there are some privacy concerns. When do you share that? When do you not share that? How many of you have ever had an app on your phone and it asks you, hey, do you want to share your location? And you wonder, why is that app wondering if I can share my location? So having students think about that, not to get them all overly worried about it, but just to be thinking about as they work through their computerized world, right? How do they share? When do they decide to share? And so this Strava map, which was really fascinating, here's an example of a compilation of millions of people's fitness walks. So I can see which parks in a certain neighborhood like this one are very popular. And here's a track around a high school that lots of people had walked around, and they had shared their fitness walks. So I can see which parks and tracks are more popular with people and which are less. And there were some privacy concerns related to that. Speaking of which, just one more thing about location privacy. Sometimes we get emails from well-meaning educators that say, I've mapped all my students' locations in a story map. Not a good idea, right? And made it public. Not a good idea. Okay, so there are some, you know, there's a lot of power that you have at your fingertips, but you want to be conscious of who you're sharing it with and what they're sharing in that. So in my story map that I created, as you saw earlier, this thing here, I actually have a picture, right, for the teacher, and I don't actually ask them their name because this is public. I don't ask them their name. I usually ask them for some sort of code, like Joseph Loves Maps, or something like that. They make up a name for themselves. So there are things that you can do, and we'll talk more about those if you'd like to. But anyway, just a couple of things to share about location privacy and being critical of data. Last note about being critical of data, and that is I've got a presentation about data quality. I just wanted to share a couple things with you. And the reason why I'm so concerned about this is that, as you talked about briefly yesterday, maps tend to be believed, right? So take a look at this map. What's wrong with this picture? Yeah, what's wrong with this one? The Indian Ocean has been, it's continental drift, right? The ocean has sloshed over to the wrong ocean. And then also, what's another thing that's wrong? Argentina is now where Colombia is now. So, but hey, it's on CBSDFW.com. I mean, isn't that a reputable source? So let me show you a couple more. This is one of the ones that it really bothers me. These kinds of maps, the favorite food. You know, a lot of these have a very low N value, you know, the number of people that they surveyed for the map. But since they're a map, people tend to believe them. So, hey, are you from Texas? Do you like stuffed avocado? We'll put it on this map. That's the favorite food in Texas. Really? I've never even had that. I don't even know what it is. I can imagine what it is, but I've never had one. So, you know, again, you need to be critical, and students need to be critical of these. Here's, Hong Kong has been migrated to South America. Now, I'll pause for a moment while that pops up on your end. But hey, it's on CNN. Okay, one more. I know it gets hot in Texas, but I'm not sure if it gets this hot. Check this one out. How do you like this one? In Cleburne, it's 3,276 degrees. This was on a live weather feed that I was using for about a year before it was corrected. And so, and look at how windy it was, 255 miles an hour. And look at the humidity. And look at the precipitation rate. I mean, this is like Noah's Ark, right? This is a major flood. So sometimes it's not just the maps that are wrong, it's the live feeds that come from. So again, just be critical of the data. Know where it's coming from, have a critical eye on it, know what the sources are, who created it, and why. All right, enough of that, right, folks? So last thing here, there are several moving parts, right, with geotechnologies. Again, we don't want you to take all of these in these 2 days and use them all on Monday, the first day of school. That would be impossible. Take the pieces that really resonate with you, and as we go through these activities, again, think about, you know, I'm not teaching about watersheds, but I'm teaching about famous historical novels, or famous people in literature, or history of West Texas, or whatever you're teaching, right? Think about how you might be able to apply these to your own teaching world, okay, and your own subject. All right, so as we go into the first activity here, does anybody have any questions, comments, concerns?
Yeah, this one.
I just want to say I'm enjoying myself. I'm a math teacher, and I was thinking of a lot of ways we could do composite figures with the measurement tool. So thank you.
Oh, you are so awesome. There is a, let me pull this up. We should talk more. A colleague and I wrote a book called Spatial Mathematics. So it's all about integrating math, geography, and GIS. It might be something that you might be interested in. There's some additional ideas there. But even as we work through things in the classroom today, in the workshop, one of them is food expenditures. So it has to do with maps and geography, sure, but it's also about ratios, about getting students to think about tables of data and how the ratios were computed, and so on. So there's a lot of decent math integration in a lot of these lessons. And so, yeah, I'm glad you're here. Awesome. I love math teachers. What's not to love? Okay. All right, folks. Yes, sir.
Can you clarify what the level of focus is for that book? Is it K-12 or is it mixed?
This book is really aimed at the university student. However, there are a number of approachable activities that secondary could use.
Right.
For example, if you're making a map, let's just pull up ArcGIS online, okay? Let's say you've got ArcGIS online and you want to make a map. How do you make a map in ArcGIS online, folks? So you get this screen, arcgis.com, on your own device. What do you do at this point?
Click on map.
Click on map. Awesome. See how you folks are? You're awesome. So you click on map, and let's just take a really simple example that is a little bit of a math integration. It has to do with precision as well. So let's say that I wanted to input some coordinates. Okay, so let's say I wanted to input some, so like you were out in the field yesterday, right? And you saw that if you do not type in negative in your table of data, you get a positive longitude. Where is positive, like 106 degrees longitude? 106 east. It's in Asia, right? So if we typed in the upper right-hand corner of the map, 31.0, let's say, and then how about 32.0, and then comma 106.0. If I type that in, 32.106, I'm going to add it to map notes. Remember how we did that yesterday a couple times. And if I zoom out, I want to find out where I am. 32 north, 106 west. If I zoom out ever so carefully here. It doesn't look anywhere that I'm familiar with. I'm going to keep going. You keep going on your device. So in the upper right, I typed in 32.0, comma, 106.0. And I'm in some mountainous terrain here. I don't see many roads. This looks pretty remote to me. 32, 106. So 32 north, 106 east. Wow, look at this. I'm going to keep going. I'm in west central China, aren't I? So coming back to the math integration, if you said, hey, remember in math class how we talk about the Cartesian coordinate system? And if we overlaid the Cartesian coordinate system on the globe, what would be our x-axis? What would be our x-axis if we overlaid the Cartesian coordinate system on the globe? The equator. Yep, good. What about the y-axis? What would the y-axis be? The prime meridian. Awesome. So in the Western Hemisphere, right, show students an actual globe. You know, actually show them a physical globe if you've got one in the classroom, and show them, okay, if we overlaid the Cartesian coordinate system on the globe, and the prime meridian is 0 degrees longitude, which is the y-axis, correct? And Texas is left or west of the prime meridian, correct? So therefore, the x values are negative, right? The x values are negative. The y values are positive, right? Because we are truly north of the equator in Texas. I know it doesn't feel like that sometimes. You probably feel like you're on the equator because I know it gets pretty roasting hot down there, as it does in Denver where I am. But it's a good integration here of the coordinates. So if I type in 32 minus 106, then I'm going to be a little bit closer to El Paso, right? 32.0 minus 106. Let's see where I end up. So 32 minus 106. The reason why I'm truncating these actually has a purpose, which I'll explain in a moment. You probably know where I'm going with this, right, folks? So if I go to 32.0 minus 106, I'm going to be a little bit closer to home. Not exactly, but a little bit closer. So now I'm zooming out, right, either with the minus sign or I can zoom out with the mouse or the touchpad. And now you can see that I'm right on the New Mexico-Texas border, right, which is actually supposed to be right on 32 degrees north. So I typed in 32 minus 106. And the reason why I did that is because, okay, the minus actually matters, right? So the longitude is negative because we are left of the y-axis in Texas. Indeed, most of North America, except for the little piece of the Aleutian Islands, right, that actually extends into the Eastern Hemisphere. That is a positive, that's the Eastern Hemisphere, so it's positive longitude. But here in Texas, we are 32.106-ish. Now, sometimes when students are out in the field or when they're in the classroom and they're entering coordinates, and they're building those spreadsheets like you guys did yesterday, they may wonder, or they may ask you, hey, do we need all these significant digits? Can we just round, or can we just truncate? And you can turn that into a nice little, maybe 5 or 10 minute lesson that, okay, let's try it. If we truncated or rounded to the nearest longitude and latitude, we're up in the Texas-New Mexico border, right? So if I hit that measure tool and I measure from that point over to actually El Paso, it's 29 miles off, right? It's 29 miles off. So if you're doing regional studies, it might be okay. But if you're trying to locate a shrub on the campus of the Isleta Middle School, that's not going to be accurate enough, right? So significant digits matter, which is another good math and science point, you know? So now if we said, well, okay, what if we added a significant digit here and called it 32.7, comma, I'm just tweaking the number in the upper right, 106.1, 32.7 minus 106.1. And if I searched for that and added it to map notes, then I zoom out, Sorry, I need to go to 31.7. 31.7, 106.1. I add that to map notes. Let's see where that puts us. (31.7 minus 106.1). Okay, now we're a little closer to the middle school. Now, instead of being on the New Mexico-Texas border, right, we are now, well, I don't know, let's grab the measure tool and find out. We are now about 14 miles away. Okay. You see where I'm going with this, right, folks? Now, if I typed in 31.70 or whatever your numbers were from yesterday, I'm kind of making this up because I don't know exactly what your numbers were. But if I typed in all of the digits that I had at my disposal yesterday when I was out in the field, which is usually about 5 or 6 significant digits behind the decimal point, again, keeping the minus in front of the longitude, if I typed in all of those significant digits I had from yesterday into the system, and then if I zoom out, now I'm in a neighborhood in El Paso that's actually fairly close to where you are. So significant digits matter, and just by gradually adding more significant digits to your points and then measuring how close you are to the school at each point, again, this could be a 10-minute lesson. It could be a half hour. It could be your whole class period, depending on what you want to do. But that's just one example of, you know, doing something that you already know, using a platform that you already know, ArcGIS Online, and just typing in coordinates. Does that make sense? Okay, cool. So up in the upper right, you saw that you can type in latitude, longitude coordinates, you can type in street addresses, you can type in cities, etc. That geocoding tool is fairly powerful. However, I think it's good to know that students need to be pretty accurate about what they're typing in there. So again, negative for the longitude if you're talking about Texas, positive for the latitude. And then just one last math thing. Notice that I typed in 31 and then minus 106. 31 is the latitude, 106 is the longitude, right? So it's latitude, longitude. But if you think about the math, is that XY or YX? (31, 106). Is that XY or YX? It's YX, exactly. It's the Y is the latitude, the X is the longitude. So this is a case where our language kind of gets in the way. Not gets in the way. It provides a nice teachable moment, right? So common everyday speech, we say latitude, longitude. In terms of mathematics, what we really should be saying is longitude, latitude, right? Because the longitude is your X, your latitude is your Y. Awesome. Oh, you folks are great. I love working with you. All right, let's go into our outline. And our outline is that document that we've been working through. And so I'd like you to pull that up because we're going to commence with a geo-inquiry. And as we do, just a couple notes about teaching resources. So go ahead and pull up that document if you don't already have it up. That'll be our good guidelines. All right, so you've got that document rolling. Keep that handy. Keep that in a tab, or in this particular case, Dr. M has printed out the activity that we're going to go through here. And just a note on that, if you've got multiple monitors in your classroom per student, which is pretty rare in a K-12 school, but if you've got multiple monitors, I think it's very handy to be able to have one monitor be the lesson and the other monitor be the map that they're working with. If you don't, then you can still do it. You can still have, you know, it both digital, but it's just that the students will have to kind of raise and lower the lesson. So it's a little clunkier, but they're usually pretty good about doing that. Another way of doing it, of course, is actually printing the lesson, as Dr. M has done for you today, which I think is very helpful, especially as you're kind of getting into this. It's nice to be able to look down at the lesson. And that's actually a viable way to do it as well. So I'm going to go into this remote sensing geoinquiry. As I do, just a small note about lessons as you're pulling that up, folks. First of all, there are no shortage of lessons, okay? And I'm going to show you just 4 bodies of content, 4 bodies of lessons here. First of all, if you go to esri.com/geoinquiries, you're going to get this. You're going to get a bunch of geoinquiries, and let me just pull that up. esri.com/geoinquiries. As you know from yesterday, these are short, could be 20 minutes long, could be a whole class period, could be a couple class periods, but on certain topics in primary and secondary. American literature, earth science, environmental and government, math, human geography, etc. Okay? So there's about 150 of these, and you can use them. You can use the maps that are associated with them. You can use the questions that are associated with them, or you can say, hey, Joseph, I've got my own questions. I'd rather use my own questions. I like these, but I like my own better, and that's fine too. So there's a lot of different ways that you can teach with these. Let me also mention that we've got a couple of other bodies of similar kinds of lessons. And so ESRI UK, so we've got a group of educators and folks over in the UK that created a separate body of content. Sure, many of them are UK based, but some of them apply to everywhere in the world. You know, some solid geography content and earth science, and they're big on field work over there. It's actually embedded in their K-12 curriculum, which is really wonderful. So ESRI UK has a body of lessons, and also ESRI Australia. Good day, mate. She'll be right. ESRI Australia, if you look at their classroom learning materials, they've got a body of lessons as well, ranging from palm oil, as you can see here, to one of my favorite ones that they've actually got. It's a little grim, but they've got one on sea level rise right here. So it's in 2D and also in 3D, and so you can see, 1 meter, 5 meter, 10 meter potential sea. I think it's 1, 2, and 5 actually. 1 meter, 2 meter, and 5 meter potential sea level rise, and getting students to think about coastal vulnerability and how many cities are near coasts and so on and so forth. Okay, so that's ESRI Australia. The last body of lesson content that I wanted to let you know about was this site called Learn ArcGIS. So these are, as you can see, lessons. Once again, they're based on a problem or an issue. So instead of being grouped by human geography, earth science, mathematics, they're on a broader context. They're more on, okay, let's look at wildfires, or let's look at city planning or hurricane damage. So these are structured differently. But I think, especially for you secondary teachers, I think that once you get students moving along with GIS, this would be not a dip a toe into the shallow end of the pool. This would be more of a mid swimming pool level, maybe a little bit of a deeper dive, okay? But it's still something to keep in mind, because once again, you can design your own questions. These maps will open, and you can say, that's maybe a bit too advanced right now, or not exactly what I'm teaching, so I'm going to make up my own questions based on this map. So that's the Learn ArcGIS site, many of which are based on ArcGIS Online, but not all of them. So there's some that are based on other tools that we'll maybe talk about more later on in this workshop, okay? I think you folks should start with ArcGIS Online. I really think that the online platform, as you saw, any device, anywhere, that's the way to start. So anyway, those are 4 bodies of content: the geoinquiries, the ESRI UK, the ESRI Australia, and the Learn ArcGIS body of content. Okay, so we are going to start with this. I'm going to actually get rid of some of these tabs just to save a little bandwidth here. And let's go ahead and I'm going to go back to my outline. And the remote sensing geoinquiry. Now, as you folks know from starting with this yesterday, each one of these geoinquiries starts with a map. right? And that map has no login required, right? So if in your outline, you might want to click on the geo inquiry. I know you've got it printed there, the remote sensing one. I'm going to open the remote sensing geo inquiry. And basically it asks you to start getting into looking at imagery on the Earth and asking some questions about human environment interaction, river systems, and so on. We did a little bit of this yesterday when we looked at the Change Matters viewer, where we looked at Mount St. Helens and the Aral Sea and so on. Remember that? All right, so I'm pulling up this PDF in the GeoInquiries remote sensing. And it's got a couple of links there, in this case to the science standards, because this particular one is actually located underneath the science body of content. And we're looking at place-based hazards using remotely sensed data from satellites, aircraft, drones, UAVs, in this case, mostly from satellites. And we're looking at landslides in this case. Okay, so if you've got the printed version right there, you might have to just type this in, but fortunately we've created a kind of a easier to type in URL. So this esriurl.com Earth GeoInquiry 2 is what I'd like you to type into a separate tab in my PDF, the online PDF. It's actually linkable, so I can just go ahead and click on it. But if you've got the printed version and you don't have the document in front of you digitally, you might have to just type this into a tab.
Sorry, Dr. King.
Yep.
It is coming a bit. So in the folder of resources that we gave you guys yesterday, through Dropbox or through landslides, there is a subfolder that we call GeoInquiries. So if you go into that folder, you already have the PDFs. You don't want to download. So just open that PDF and click on the link. It's live. You don't want to type in the URL. Okay? All right, Dr. King.
Thanks, Dr. M. How are you folks doing? Did you open up we've got two things that we should have either in printed, one of which could be in printed form, and that is your lesson, and you also have the map, correct? So I've got the lesson here called remote sensing, and then I also have opened up the map, which looks like just right here. It's pretty simple. It's basically a shaded relief map. It looks like I've got a river running through here, and a town, and a highway. Okay? All good? Yes. All right, super. I'm going to go through just a minute or two of this, and then I'm going to turn you loose for about maybe 5 or 6 minutes and have you work through some of the questions. But the first thing that I just would like to highlight is that every single one of these maps that's tied to a GeoInquiry has a series of layers. And if I go to the Content tab, right, the Content tab to the left of the map, I can see the layers that are in here. This is the Oso landslide in Washington State, which happened a few years ago. What you've got is a hillshade pre and post landslide, and then also an image after the landslide and an image before the landslide. So the idea here is getting the students to think about natural hazards, in this case, landslides. So you've got, in this case, 1, 2, 3, 4, 5 layers: the topographic map, the pre-landslide, the post-landslide image, the hillshade, and then areas of interest. So in the lesson, it actually gets the students to think about, okay, what does an area prone to landslides look like? So get them familiar with the mountains, the hills, the rivers around there, and then getting into the human aspect to it. How many people can a landslide impact? So they do a little measuring of the number of houses in the area, and then thinking about, hey, well, if this is prone to landslides, could they have seen it coming? And then, okay, what part of the river might the river have played in it? And then coming back to, well, what's the safer place to live if you're staying near the river? So you do a little bit of measurement, you do a little bit of turning on and turning off the layers. Nothing too intense in terms of GIS, but I think it's a powerful lesson in that what we talked about yesterday, you know, what are the natural hazards in El Paso? It might not be landslides, right? I know you've got other hazards like we talked about yesterday. So getting the students to think about your own area. So I'm going to turn you loose there and have you work through a couple of those questions for the next 5 minutes or so. And meanwhile, if you've got any questions for me or your other instructors that are around, feel free to ask. So, all right, folks, onward.
Thanks, Dr. K. You can bring a cup of tea.
You're all done? You kind of get the idea, right, folks? All right, super. Did you like the questions that were posed in the geo inquiries? Okay. Did you start thinking about maybe other questions you could ask? All right. That's what I love about these, is that you can use the questions that are there, but just like other curricular materials, you can design your own. The nice thing about geotechnologies is that since you've got the maps, the data set at your fingertips, you have the power, right? You can go beyond the questions. You can use some of them, none of them, all of them. One of the things that we talked about in terms of extending the lesson would be, okay, let's go to El Paso now. Let's look at our own community and talk about the hazards that exist here. Okay, that was one thing that we talked about. The other thing, and as I was looking through this post and pre-landslide, I was thinking, you know, this is not the whole story, right? You would have the students, I think, do a little research on that landslide and find out what happened, why it happened, etc. Right? You'd actually bring up maybe a newspaper article online or something like that. Have them or have you do a little bit of research on the event. So it brings it to life a little bit more, right? Because there's not that much in the lesson that talks about what actually happened a couple years ago. And if you've probably zoomed out and found out where this was, right? So that you've got that at your fingertips as well, right? You've got the capability of zooming out on these things. Where is this? What part of the world? Washington State. A long ways from El Paso, right? Different kind of terrain, as you saw, different kind of vegetation. So get the students thinking about one of those questions I thought was really intriguing. One of those blocks of questions in the lesson was where we have asked, could they have seen it coming? So when I was thinking about, okay, if I were teaching this in the classroom, what enhancement would I make to it? One really easy enhancement, I think, is to go to another mapping platform, go to Google Maps, and see what it looks like on the ground there, right? See what the street view looks like. Who's used street view in the classroom ever? Okay, couple folks. It can be really interesting. You look at different infrastructure. You can look at housing type around the world, right? Different kinds of vegetation, you know, the taiga biome, the chaparral biome, etc., as it actually looks like on the ground. In this case, I went to that same location in Google Maps, and this is what it looks like. Now, interestingly, you got to pay attention to the street view date. Okay, and if you've done a little research on the landslide, you know that it happened actually a few years ago, 2014-ish, 2013, 2014, 2015 maybe. But anyway, the point is that it actually happened after the street view was taken in 2009. So when the landslide happened, are you folks seeing this image okay? Okay. This is what it looked like on that state highway right there at that spot. So as you can see, I'm looking north. You could see the little street view person in the map in the lower left, looking due north right now, and look at the vegetation there. That hillside north of the river is completely obscured by trees. And so it's a little bit grim to think about, but if you basically, this is what it would have looked like when the landslide rolled through, right? Because it didn't change that much between 2009 and the time of the landslide. I mean, the trees might have gotten a little higher and so on. But the kind of the grim thing to tie into that lesson was, are you going to see something rolling through? Have you got the view of the hill slope obstructed? No, you're not going to see anything at all. You're going to hear a bunch of noise, and then sadly, the landslide is going to go rolling through. So getting the students to think about, no, it's easy for us to say now, oh, they should have just gotten out of there, right? All those people should have evacuated. But what are they going to see? They're going to see a bunch of trees. That's all. So that's what it looks like on the ground, and that's what it would have looked like at the time of the landslide. So that's just one little enhancement that might take 5 more minutes of your time in the classroom, but I think it's one of those things that really would deepen their understanding of what exactly happened. And then, of course, then go to hazards in El Paso and maybe use a street view. What happens if the river floods or a tributary floods, or you've got some sort of wildfire or any other hazard that you folks deal with on a regular basis. Okay, so that is an example of a geo-inquiry. Let's go to just one more ever so briefly, and that is this one called Down to the Last Drop. As we go there, this is in your outline. Do you have any questions about that particular one? No, I'm really curious. I don't exactly remember when that landslide happened. 2014, 10:37 a.m. So it was in the daytime. It was in the morning. And, but again, no warning, right? 49 homes destroyed, etc. So, okay. Down to the last drop. This is part of the environmental science group. And if you click on the link in the outline that we're working on today and tomorrow, or yesterday and today, you'll get a PDF there and a little bit of metadata about the information that is contained in the map and in the lesson. If you've got the paper copy, by all means use that, but then you'll have to type in the URL for the map once we get there. Now, just a word about this interdisciplinary nature of these folks. You know as well as I do, otherwise you wouldn't have such a diversity of wonderful educators there in the workshop today. But even though this is grouped in the environmental science group, does that mean you can't teach with it if you're in math, or if you're in the library, or if you're in some other discipline? No, you can definitely teach with these. You might have to adjust some of the questions, but you can definitely use these. Don't get locked into teaching. I can only teach the environmental science group if I'm teaching AP Enviro. No, just kind of look at them, get familiar with what's there, and say, okay, I can use these. And again, thinking about our comments earlier today, this is one way, it's not the only way, but it's one of the easiest ways to sort of get you and your students into geotechnologies. The reason why is because you're starting with a lesson, and each lesson is tied to a map. So in my way of thinking, it's one of the easiest, gentlest, bite-sized, gluten-free ways of getting into geotechnologies. This particular one is exploring the impact of human activities on water resources. I used to work at U.S. Geological Survey, so this is kind of near and dear to my heart, and hopefully to yours as well. Water is pretty important, right? In Texas and Colorado and most other parts of the world. And it's amazing to me how little students know about water, right? Where it comes from, why it's a precious resource. Hey, I just turn on the faucet and there it is. Well, yeah, but how do you conserve it? Why should we conserve it? Where did it come from? What's all the engineering that took place to get it to you? And so on. I have a course at the University of Denver, and even in my university level course, and even though that's in Colorado, where just like Texas, water is an incredibly important resource, students know, by and large, very little about it. So anything that we can do to nudge the needle forward in their learning about water, to me, is good. All right. So I'm going to pull up the map that's associated with that lesson. And I'd like you folks to do the same. So we're going to have two things. We're going to have the lesson, and we're going to have the map, just like we did with the OSO landslide. Now, we looked at this area yesterday ever so briefly with a different tool called the Change Matters Viewer. Remember, we had those Landsat satellite images of different places around the world. We started with Mount St. Helens. We looked at the Aral Sea ever so briefly. So this one actually gets you into the Aral Sea in more detail. And the content, as you click on content to the left of the map, you'll see that this one has about 7 or so layers in it. The rivers that feed into the Aral Sea, the irrigated lands, and the satellite image going way back. Even we've got a black outline back to 1960, before satellite images actually existed. We had maps, and we traced the map with an outline. So you can see the extent of the Aral Sea at that time versus today. So the guiding question, as you see in the lesson, is, can human actions alter water resources? And with this map, I'm going to give you just a couple minutes to go through some of the questions and to experiment with the map, and I'll sum up here in a couple minutes. I'm not going to give you as long as we had with the OSO, just in the interest of time. Hopefully you'll get an idea of what this lesson is about and why it matters. But I'll join you back in about 2 minutes, okay? Map on.
Thanks, Dr. K.
All right, folks. You saw how with just a few layers and just a few guiding questions, you can turn this into a really powerful learning experience, I think. Thinking about what we talked about yesterday. What's where? So where is this? Yep, Aral Sea, where is it? Where is this? Central Asia, thanks. Okay, so what's where? And so to me, if you're seeing this screen, an easy way to start the lesson, I think, would be to change the base map to something like a National Geographic base map, as you can see right here on this screen, hopefully. So they see the countries that are there. And if you need to zoom out a little bit more, feel free. You know, there's the Caspian, there's Afghanistan, here's Russia way up to the north, Kazakhstan, Uzbekistan. So it's right on the Kazakhstan-Uzbekistan border. Yep. So that would be, to me, it's not part of the lesson to change the base map, but you know that you can do that. And so you can change it to, again, this is a National Geographic base. No problem. Took all of 10 seconds to do. Another interesting thing, I think, germane to the lesson is that even though the Aral Sea is right here, I've got the watershed dams turned on, that layer, and the students can see that there's all kinds of dams way out to the east, all the way into Kyrgyzstan, and even Tajikistan, and even Turkmenistan, that affected the Aral Sea, right? So it was a very wide region of diversion of dams that caused the Aral Sea to shrink. So what's where? You know, why is it there? Why is the Aral Sea there? Well, these two major rivers flowed into it, kind of like the Great Salt Lake. You know, it's an enclosed basin, right? Nothing flows out of it, just having rivers flowing in. And if you block those rivers flowing in, there's going to be less water in there. And so then the third component, you know, what's where? Why is it there? Why do we care? Why do we care about the shrinkage of the Aral Sea? So what if it dries up? Well, then you dig into the lesson, right? There's social consequences, there's economic consequences, and there's human health consequences. So the economic ones, you could show students, for example, pictures from National Geographic of boats that are sitting in the sun, you know, that are 20 miles from the water, from the current water line. And so the whole collapse of the fishing industry, right? Because it's not just that the water has decreased, but the chemistry of the water has changed. So it's a dead zone, that the fish cannot live in there anymore. And then the human health consequences, you've got this, for example, dust impact. It's not just that this dust impact, and you can measure this, right? You can measure the extent of the dust impact with that measure tool, but that it affects a huge area. And it's not just that it's dusty, but it's these salts and things that were on the lake bed in the past are now airborne. And so there are all kinds of respiratory illnesses that people have had in the region because of the Aral Sea. It's one of those classic things where you can introduce the students, well, you know, we've done some things to the landscape, and you know, there were some valid reasons to do it, right? It's basically, as you saw, to grow cotton in this irrigated area. So, hey, we want to be sufficient in cotton production. We're going to divert these rivers and grow cotton, right? Do you have that in Texas? Growing cotton in the middle of a dry area? Yeah, sure. I mean, I've been to Texas Tech, and just south of there on the Llano Estacado is all those cotton fields. And in that case, as you know, it's pulling water from where? It's not some major river that was diverted, but yeah, the Ogallala Aquifer. So it's mining water from that aquifer. So there's something that's actually closer to home that the students might be able to identify with. So it's one of those things you get the students thinking about, you know, we make decisions on the landscape, and you know how oftentimes students, they kind of divide, oh, it's either good or bad. Well, it's one of these gray areas where some people benefited. People were employed, they became self-sufficient in cotton production, or nearly so, you know, but there were some consequences, there was some harm. And then the last part of the lesson I like as well, because it brings it a little closer to the United States, where you can look at the lower Colorado River Basin dams and canals and look at that. And how did I do that? I went to that layer and I said zoom to. With the triple dots, I can just zoom to it. So now I've got the same lesson, the same layers, but now I'm just looking at the lower Colorado, okay? And looking at, hey, you know, we're kind of doing the same thing in other places with some consequences, right? We've backed up Lake Mead, Lake Powell, they're decreasing in level, right? Because of municipal uses in Las Vegas and Los Angeles and other places. So this happens in other places around the world, and getting students to think about, okay, well, now that I've looked at the Southwest United States, are we doing anything like that? For example, maybe even in Texas, right? And so we can integrate cotton production. So you could pull up another layer and look at ag in Texas. And how do I do that? I modify map in the upper right. I hit the add button and I look for some agriculture layers, okay? So that's another way of extending the lesson. So in my way of thinking, folks, this is not like bumper cars, or am I dating myself? You know, have you ever been to a county fair or a state fair where they've got bumper cars? Yeah, okay. And you can only go in a certain space, right? You can't bring those bumper cars outside the track. But with geospatial technology, right, you're starting with a map with a bunch of layers, but you can add to it. You can actually go farther. You're using the same tools that state, local government, nonprofit, industry, et cetera, use. It's not like we're creating an educational version of this for you all to use, all y'all to use. It is the same tool that other people use outside of education. Now, that is a good thing, but it's also, I recognize, a bit of a challenge for you in education, because you've got to figure out, okay, how do I get this to actually work in the classroom? And I think these lessons are one way to do that, okay? All good? Todo es bueno, okay? Muy bien. Okay, let's move on. And we're going to have a break here in a moment. Let's do one more investigation, if you don't mind. Let's look at this third investigation in our outline, this demographics of the USA. This will take us 5 minutes. It's really powerful. It's national, but it's also local, getting students to think about so much natural hazards or like physical geography kinds of stuff. We're looking at sociology, human geography, human behavior, a little bit about that, okay? All right, so let's go ahead and in the outline, and hopefully you have a digital version somewhere pulled up. Go ahead and click on that demographics of the USA. So unlike the last lesson we looked at, which had a bunch of global data in it, this one is just focused on USA. and we're gonna get down to really local level stuff here. I love this stuff, folks. Are you folks doing okay? Everybody good? I mean, seriously, what's not to love? While you're pulling that up, I've got a song. Okay? I just want to break up the investigation here. You guys ready?
Ready?
Down in the West Texas town of El Paso, I fell in love with making maps. Out in the field I was with my smartphone, collecting shrubs and feeling grand. All of a sudden the school bell rang, back to the building I ran. But all the while I thought of my point file, sitting there waiting to be mapped. That's my song. I know that was so bad, so bad. Muy mal, muy mal. Oh no, seriously, don't encourage me, folks. Don't encourage me. That only makes me want to do more. All right. That's the kind of crazy way my mind works. I like to integrate music and geotechnology. Okay, so you've pulled up this map, correct? So this is demographics of the USA. I clicked on that in my outline and I get this.